Hello everyone, welcome back to Algebra 1-2. In this lesson we are talking about dividing polynomials using synthetic division. And so in this video you will learn how to use synthetic division to divide a polynomial. Now what exactly is synthetic division? Synthetic division is a quick method of dividing polynomials. It can be used when the divisor is of the form x minus c. And to rub that in a little bit more, it can only be used when the divisor is of the form x minus c. If the divisor is not of this form, we cannot use synthetic division at all. In that case, we would have to use long division to divide out our polynomial. But once our divisor is of this form, x minus c, we can use this technique called synthetic division. Now, what is the difference between synthetic division and long division? Now, here we have two examples of dividing out the same thing. We have 2x to the third minus 7x squared plus 5, and we are dividing by x minus 3. Let's look at the long division first. So we're dividing by x minus 3. We write out our expression here, 2x to the third. So we write it out here. Notice that there's a 0x here, representing the fact that there's no x term. And when there's no x term, when a term is missing, I should say, we should always try to fill that in by writing in a 0 for it. It kind of makes things easier. And so now we want to divide by x minus 3. So x into 2x to the third would leave us with a 2x squared. And then we do our subtraction there. And we continue out and we get our remainder of negative 4. So this is our divisor. This is our quotient, and this down here is our remainder. Now notice that we're using the x's right through the division process here, but we do get our remainder, we get our quotient, and we have our divisor over here, which is x minus 3. In synthetic division, it's a little bit different. We do not use the letters at all. All that we use are the coefficients. So the coefficient of the x cubed is 2. Notice that we have the 2 here. The coefficient of the x squared is negative 7. Notice that we have put it here. There is no x term, so we put a 0 for the x term, and we write the 5. And now we are going to look at the divisor. Here the divisor is x minus 3. But we do not use the divisor as is. Rather than using the minus 3, we use a plus 3. So it's kind of like saying x minus a equals 0, and therefore x is equal to a. And this is what we use when we are doing synthetic division. So here it says x minus 3 here, but notice that we use a positive 3 and not the negative 3. If this was a negative number, then a positive number, then of course this would be negative. All right, so in synthetic division, we set up our algorithm like this. So here's the number that we're using to start. Here are the coefficients of our terms. And what we do is that we take this 3, we multiply that 2. So 3 times 2 here would give us 6. Then we add 6 and negative 7. That would give us negative 1. 6 and 7 give us negative 1. Then we multiply that negative 1 by 3. This 3 times negative 1 is negative 3. Write it here in the next column. 0 plus negative 3 gives us negative 3. And then we multiply again. 3 times that negative 3 gives us negative 9. And then we add here 5 and negative 9, and that gives us negative 4. So this number here at the end is our remainder. As you see, notice it's the same remainder that we get when we're dividing using long division. And our quotient, which is here, 2x squared minus x minus 3, this is it, 2x squared, this is the coefficient, minus x minus 3. And of course, the quotient is always 1 degree less than what we're dividing by. So here we're dividing by x into x to the third. So the quotient has to be less than, the power has to be less than 3. So we start at x squared, hence that. So we're going to try out now the idea of dividing our polynomials using synthetic division. Let's start off with this one. So we have 2x to the third minus x plus 4. Notice that we don't have a square term here, so let's write it out again. 2x to the third. There's no square term, so we're just going to write 0x squared minus x plus 4, and we're dividing all of this by x plus 3. So in setting up the synthetic division, we're not going to be using 3, we're going to be using minus 3. So let's write our minus 3. And then let's write out our coefficients, which are 2, 0, -1, and 4. So we're not going to write anything under this 2. We're going to leave it as is. And we're going to start by multiplying 3 times this -2. 3 times this -2 here gives us a -6. We're going to put it here. Let's put a plus to remind ourselves that we're adding. Now we can just go ahead and write on that 2 there before. Now let's 3 times 2. -3 times 2 gives us a -6. -6 plus 0 is -6. We write that down. Now we're going to multiply this -3 times this -6. That gives us positive 18. We're going to write it here. And positive 18 plus -1 gives us a positive 17. And then we're going to multiply again -3 times 17. That gives us a -51. And then we add that -51 to this positive 4, and we get a -47. So go ahead and let that soak in, or let's try it again. Notice that we start off with our first coefficient here, 2. That's what we start off with. We write it here, and then might as well write it at the bottom here. But we don't do anything else with it apart from multiplying it by this -3. So -3 times 2, -6, we write it there. Let's use a different color for that. And we add these two, and that gives us this -6 here. And then this -3 multiplied by this -6 gives us a positive 18. We write it there. This -1 plus 18, we add those two and put our answer here. And then this -3 times this 17 gives us -51. And so we add these two and put our answer here. And pretty much that is it. It's finished. What we need to do now is just to write up our answer. So the quotient would be, remember it was to the third, so we start off with square. So it's going to be 2x squared minus 6x plus 17, and we have a remainder of -47 over what we're dividing by. We're dividing by x plus 3. So this is, as you see, it's a faster way of getting to our quotient or getting to our remainder by using synthetic division. It's really, really faster. The only limitation is, as we say, is that the divisor has to be of this form. It cannot be of any other form. It just has to be of this form. That's the only limitation. But it's very, very useful. And as you can see, very, very quick in getting to our answer. Let's try another one. So here we have 4x to the third minus 2x squared minus 10x plus 1. And we're going to divide that by x minus 2. So our coefficients are 4, 2, 10, and 1. We have all of them, so we don't need to put any zeros in there. 3, 2, 1, 0. Very good. So here we notice here we have a -2. And we are going to use x equal 2 to start our process. So we're going to write down the 2, and then we write out our coefficients, which are 4, -2, -10, and 1. Let's draw our line. Now, for this 4, we can go ahead and write back this 4 here. And then we're going to multiply now 2 times this 4. So 2 times 4 gives us 8. Now we're going to add here 8 plus -2 gives us 6. 2 6s are 12. We're going to put that 12 here and add 12 plus -10. 12 plus -10 gives us a positive 2. 2 2s are 4. And we write that 4 here. And so 2 2s 4. 4 plus 1, we add that. And we get 5. So our answer is going to be This was cube, so we're going to start at square. 4x squared plus 6x plus 2, and we have a remainder of 5 over what we're dividing by, x minus 2. So it says find the quotient, and the quotient would be this. This is our remainder. 5 over x minus 2 is what our remainder is. All right, let's try another one. Here we have let p of x is equal to 3x to the 5th power plus 5x to the 4 minus 4x to the 3rd plus 7x plus 3. And we want to find what the quotient and remainder are. And also find out what is p of minus 2. So notice 5, 4, 3, 2, we're missing a term here. This square term is missing. So remember, when a term is missing, we're going to use 0 to replace it. So let's write it down. We're dividing by x plus 2. And so we're going to be using x equal minus 2 in our process. So let's write our minus 2 there. And now we're going to write out the coefficients, which are 3, 5, negative 4. Remember, the square term is missing, so we put a 0 there for the square. And 7 afterwards, and then 3. Once we have all of them, 3, 5, negative 4, 0 for the square term that is missing, 7, and 3. Now what we need to do now, draw our line, put in our plus. You can write back this 3 here to start, and we're going to say negative 2 times 3 gives us a negative 6. Add these two. Negative 6 plus 5 gives us a negative 1. Now we're going to multiply negative 2 times negative 1. That's a positive 2. Put it here. Add these two. Negative 4 plus 2 gives us a negative 2. Now we're going to multiply again. Negative 2 times negative 2 gives us a plus 4. 4 plus 0 is 4. Negative 2 times a positive 4 gives us a negative 8. Negative 8 plus 7 gives us a negative 1. And negative 2 times negative 1 here gives us a positive 2. We add these two and we get 5. So what is our quotient? First, our quotient. Remember, this started at x to the 5th power, so we must start at 1 degree less, which is 3x raised to the 4th minus x to the 3rd minus 2x squared plus 4x minus 1. So this is our quotient. Let's call it q of x. That's our quotient. And our remainder is this. Our remainder is positive 5. Now, very, very interesting when you're using synthetic division is that the remainder that you get is the same as if you were to plug negative 2 into this and work it out. So, for example, if you should, p of negative 2 here is actually equal to 5. So the remainder is actually equal to p of what? P of the number that you're using right here. So if you were supposed to say, for example, let's find p. Let me just use a different ink for that. Let's find p of negative 2, which means we're going to substitute negative 2 into this, which would mean finding 3 times negative 2 to the 5th power plus 5 times negative 2 to the 4th minus 4 times negative 2 to the 3rd plus 7 times negative 2 plus 3. Then if we work that out and you plug this into your calculator, then what you would actually get is 5. And it's very, very important that we remember that when you use synthetic division, the remainder that you get here is actually equal to the number that we're using here. So you happen to be dividing, say we are dividing by x minus a. If this is our divisor, x minus a, then we are using a in our process right here. And our remainder r is going to be actually equal to p of a, in this case, if it's our function. So we can just go ahead and write down p of negative 2, since we're using negative 2 there. P of negative 2 is actually equal to 5, rather than going through this long process and finding it, because the answer is actually there. So synthetic division is very, very interesting. It's very, very useful. The only limitation, like we said, is if you're using synthetic division, your divisor has to be of the form x minus a. It cannot be any other form. It has to be this, but it's very, very useful. As you noticed, we use it to find the function value here. And we can also use it to find our coefficient. And of course, when you're trying to factorize things like these, you can always use it to work out the linear type factors like this, so that you can break down this bigger polynomial into a more manageable form, get it into a quadratic form that you can actually factorize it. So it actually makes sense that we learn synthetic division. One, it's cool, and it's way faster in many cases than using long division. Now that you've seen it, remember to go get some practice so that you won't forget it. And if you haven't subscribed to the channel, then please do before you go. Thank you for watching, and thank you for your support.